Okay, this is question number 15. Analyze the flow between the plates of figure 1.15 by assuming the fluid is a de Wander power law fluid as in equation 1.31a. Compute the velocity profile u with the power n as a parameter. The velocity at the midpoint h over 2 for n equals 0.5, n equal 1.0, and n equal 2.0. So here we will have notes for this one in chapter 2 and chapter 3. I think we are talking about the Poisson flow and Couette flow later on. So this is just the warming up for this one. So let's say we have two plates here. One is fixed and one is moving. So I think you already know the phenomenon of no slip condition here means that the molecule here, the molecule at this area will stick very hard on the surface, so means that the u, the velocity, is equal to 0 now. Okay, so and then again at this situation the slip condition is actually occur. Okay, so but the idea of no slip here means, okay, so because it is stick very hard on this surface, so when this plate is moving at certain velocity, so we found that this molecule also move at certain velocity. It will move with a velocity, with the same velocity of the plate, which is the capital V. That's why in certain textbook they will write the idea of no slip condition, because the situation is relatively no slip compared to this situation. Okay, but if we only look at the phenomenon that occur on this molecule, we found that this molecule also, okay, we found that this molecule also have no slip condition, which means that this molecule is stick very hard on the surface. That's why it could move at the same velocity of this plate when this plate is moving. Okay, that is the idea. Okay, so the question is, we need to determine the velocity profile, and here it is very obviously we need to calculate, we need to find the velocity profile of uy. So I think you already know the idea of uy here. So uy here means the velocity of u in terms of y axis, actually means we need to see the velocity difference in terms of y axis. U here is the velocity at x axis here, as we learned in differential method. Okay, so there is a lot of molecule moving on x direction, but the equation, the profile here that we need to plot is the velocity changing, or the velocity profile, the pattern of the velocity from y equal to 0 until y equal to h. So the height is h, so we could say that until the location of y equal to h. Okay, so we go for this one first. So we need to create an equation for the velocity profile. So because the question is directly asked to calculate what is the du dy, so and then means that du dy is actually the idea is it will create a certain value, because if you write du dy is equal to 0, so means there are no changes of velocity profile. So means the du dy must have certain amount, certain value. So we could write anything. We could write c, b, or whatever, means the constant number. So why we could assume like that? Because if we see the velocity here, we found that it's u is equal to 0, but at this molecule, the molecule will moving at v velocity, because it stick very hard on the plate, and then it could move with v velocity because the plate is moving with v velocity. So and then we assume that velocity profile here is actually great. It actually a linear one, a straight line. Some profile may be curved and so on and so forth. Okay, so here, because it is linear, so we found that the du dy, as I said, the du dy means the changes of velocity along the y-axis. So means that if the line here is linear, so means that you could get a gradient value which is constant. It is same at all places. So for this curve, for example, so if you do the tangent line here, and the tangent line here, you will find that the tangent line is different. So means that the du dy is might be different. So, okay. So let's say we put b as the constant value here. So, and then we know that the du dy here is in differential form. So we need to give the velocity profile in terms of the fully developed equation. So in fully developed equation, there are no du dy, no differential term. So what we could do is we bring the dy to the right hand side. So we have this term, and then to get the full term, so we integrate both sides here. So we integrate du, which is 1 times du, and integration of b dy. So we get integration of du, so we get u. So integration of b dy, so we get by plus a. So means that b is a constant, and a also another constant. So a here is the constant because of the integration work. So, and then what we need to do, we need to know what is the value of a and what is the value of b. So, and then let's say we need to use the idea of boundary condition. So what is boundary condition? So I think I already explained it. So it is actually the condition at the boundary. So where is the boundary? So the boundary is the boundary of molecule between the liquid and the solid. So this is the boundary, and this is also the boundary. So means that you only have two boundary. Okay, so what condition that we could get? Normally we will give them the coordination at this point and the coordinates for this point. So we could substitute as at y equal to 0, u is equal to 0 because the molecule is stick very hard. But at y equal to h, the u is equal to capital V. So here we assume that the molecule is actually stick on the plate, but relatively it's moved with v velocity compared to the molecule at the bottom. So that is the idea. So we substitute this condition into the equation. So we found that u is equal by. So and then if we substitute this condition into the equation, okay, so we have the u equal by. So and then we substitute the y equal to h and u equal to v. So we get b equal v over h. So and then we could substitute the value of b into these terms. So we could get u is equal v over h y. So this is the idea. You could see that this is the equation. So when you have equation of y here, you could write u in the function of y can be written as v over h times y. This is the common mathematical expression. I think you know. For example, you have yx is equal to 4x plus 1. So we don't imagine that the value of x here is y times x. This is the function of y in x direction, something like that. Okay, so I hope you could understand the mathematical expression here. So and then the question asks about the velocity at midpoint. So we know that the midpoint is y is equal to h over 2. So and then we substitute. So we found that the velocity at the midpoint is v over 2. So means that we could say that at all the time, the velocity at midpoint at the center line is v over 2. So here you could see that the value here is actually fit with the idea of the linear. So we have a two plates here, and then the velocity changes here is linear like this one. So, and then you could assume that at the middle point here, the velocity is actually half of the maximum velocity at this point.